Hi everyone, this is just a little update on my little virus propagation simulator thing in Unity. A couple of people have asked me if they can have a look at the source code, and the answer is yeah, sure, if you want. I don't know, I mean, you can look at it. I don't know if you should look at it, because it was one of the first things I tried doing in Unity. And it's probably full of all sorts of bad practices and mistakes and things like that. But I'll give you the link to the assets folder and the project settings folder on GitHub. And I think that will be enough just to get it going. So you can have a look at it if you want. I've not finished the user interface. I keep meaning to get around to it, but basically, I'm just going to take you through all the different elements of it and show you if you can get it up and running on the Unity editor on your computer. Then this is how you'd use it. Okay, so the main bit, the way that you interact with the program is you use this scores object. And in the inspector, this has got all the variables you can change, and I've tried to put them into categories and things like that. One thing I've never got around to doing, but you can do, is there's a settings thing, and you can set the you can save the presets. I've never actually used that, but I presume you could set up a preset like you know, not using social distancing and things like that. So what I'll do is I'll just give it a quick run. I'll fiddle with the settings a little bit. Where is it? Down. And just tell you what these different features do, if I can remember, because to be honest, I've not actually used it in a little while. Oh, where is it? Self-isolation. Okay, %. So let's switch off self-isolating. And this is what politicians don't want us to do, and with good reason, I believe. But let's have a look. We just run it, and there we go. And I've changed the graphics a bit, improved them, and I've added some little particle effects just to show the ones that are infected. And we can see what's happening there. It's massive sort of upswing, and it shows you there that the high infected got to 60%. Now I'm gonna what I would have added if I'd worked on this a bit more was a little thing about, you know, when it gets to that high, let's you know, let's say, you know, this is going to cause extra fatalities because it's going to overwhelm the health service of a country. But so okay, and then it stopped. That's the simulation stopped. It stopped on day 48 because the whole thing's played out now, presumably. The deaths are a bit high. That's 21.7% high. That's too high. I need to fiddle with the variables a bit. But now we're getting a bit more data, of course. We can plug in some real statistics, and you can see all these blue ones going around. By the way, I changed it from using spheres in the Unity engine to using flat sprites of these circles. Funny enough, I don't know if I'm doing something wrong, but it wasn't actually faster. It was a little bit slower doing it like that. So Unity can maybe render untextured spheres faster than it can these quads, which make up the sprites. Okay, so I'll just take you through some of the elements on here. This bit round here, this is the canvas, and this is a text element, and I'll show you where that is in a moment. This is now, this was actually one of the most difficult bits to do, and I thought I'd be in my element because this was pure old school. You know, like you program an Amiga or an 8-bit computer or something like that. But you can see the graph and everything, and the way that works is there's a quad here, a quad object, and in the code it creates a blank texture, and then it writes all this stuff to the texture, and then every frame it has to bring the texture back down from the quad, modify it, and then upload it again to the graphics card. So it seems a bit fiddly to someone as old school as myself, but you know, obviously Unity's not really orientated around letting you do this sort of thing. So let's come back out. See what else to show people. So as I say, if you click on the scores object, then that'll give you all the parameters that you can change. I've tried to make them fairly readable. I've sorted them into sections. Total blobs, excuse me, 300. The X size and the Y size of the simulation, the X and Y origin, so if it needs to be shifted off to the side or something like that. The percent infected, that's of course the initial percent infected. So this defines a virus. One thing I want to try at some point is adding multiple viruses, because I sometimes wonder if there is more than one COVID virus going around, because the way it affects different people differently. But so there's that's the initial percent infected. The immunity period, that's how long immunity lasts, because let's just shove that in. An immunity period of 7, or an immunity period of 14. That's a nightmare scenario. So the immunity won't be long lasting. But there's the recovery period and the infectious period, because it's possible for someone to be infectious but not showing any symptoms. Infection probability 30, that's the percentage chance that one person can infect another. Oh dear, you have to excuse my throat today. Spontaneous reinfection, it's possible to give a chance out of 10,000 for someone to become reinfected just spontaneously. That, I suppose, would simulate, say, if someone from outside the simulation came in, because there's only 300 actors in this simulation. So if someone from outside the simulation came in, you know, and because otherwise the infection can drop down to 0, and I preferred it if there was a small chance of it starting up again. Oh, this one's quite important, continuous. If that's checked, so in other words, if that variable is true, then the simulation will just go on forever. If not, once the infections drop to 0, it will stop. So but obviously that can interact with the reinfection thing. There's no point in saying spontaneous reinfection unless you put it on continuous, really. Generally, the delay of reinfection, you'd have to look at the code for exactly what all these different ones do. Percentage delayed reinfect, I can't remember. It's a while since I've looked at my own code on this. I've moved on to other things. Lockdown, that's a feature that isn't finished yet, but there was an idea. I had it working partially, but it really needs rewriting. The idea was that once it gets to a certain percentage, you could get rid of the you could switch off the lockdown. But percentage self-isolating, let's put put a low percentage on self-isolation. The length of self-isolation, you can make it so that the 7 here and the 7 here means it'll be 7 days on self-isolation and 7 days off, which was an interesting scenario to explore. Again, I make no claims that this is an accurate simulator and this is what will happen in the real world, but it gave you a kind of a halfway house result where it was just like a slightly flattened version of having full self-isolation. Sorry, of having no self-isolation. And then masks, that's the percentage wearing masks. We'll just shove that on 30%. And that's the effectiveness of the masks. I have it set at the moment to 20% reduction in infection of other people. Sorry, 20% reduction in the likelihood of being infected, 50% reduction in the likelihood of infecting someone else. And I think that's probably about right. The social distancing stuff, that was never finished. There's something there for the period of reporting. Yeah, because I've added. Funny I should say let's just run it again. I'll just show you the last thing that I added. There's a variable called R, which is the reproduction rate. I think I figured it out properly. But, so here we go, quite a lot of people self-isolating there, so just staying still. But it only lasts 7 days, so every 7 days it'll flip between the two states. And everyone's moving around again now, so it's going to pick up again. You can see it reflected in the graph, whether or not they're self-isolating. Next lockdown, tells you when the next lockdown will be, 28, so there it goes. The high infected percent is getting to 22%. So you can see if you do something like this, it never gets terribly high, but I suppose it's practically never going to go away. In fact, it's only because I've got the likelihood of it killing someone a little bit too high. I think you've got to go into the code to change that at the moment, though. But so we've got the R variable. I don't quite know how that works, but that is calculated every 7 days, so it's at 0.39 at the moment. But that was the last thing that I added to it. Yeah, so you can see what that produces. So I don't know if there's anything else, if people want a little play around with it, just to see. Just excuse the code because I was learning Unity Editor, and it's the first reasonably big exercise I gave myself. What's all this? Quad texture. I can't remember. Oh, right. Yeah. So, there's maybe a couple of things that weren't used there, but I used Critter just to design some more graphics, just to make it a bit more interesting to look at. So, I don't know if there's anything else you need to know just to get going, and then look in these source code files. Movement, I suppose, is probably the biggest file in here. It just stores these variables. Some of them are, when I first started using it, I didn't understand the difference between public and private for these variables. I should have, a lot of these should be marked private, but like I say, look at this code at your own risk. It's not terribly good code, because I was learning while I was doing it. And then I moved the objects around manually, and it uses Unity's collision detection to decide whether they've collided. And I'll just show you quickly how that works. But I mean, if you download this code and there's a bit of it you don't understand, there's maybe some of it you can't believe because it's so bad. Because like I say, I've been teaching myself C# since the beginning of the year, so I wouldn't call myself an expert yet. But yeah, so on trigger enter, you see that's a mistake. Change to on enter, but that needs figuring out, to be honest. Right, but this is where most of the code is. Like I say, if you want to change how deadly the virus is, these need to be made into public variables that can be altered, but I didn't quite know how to do it. I didn't know how I wanted to do it. I was fine-tuning it, but it's a little bit apply damage, blob health -15. But anyway, every so often, maybe once a day, it applies a bit more damage to each of the blobs. The healthier ones don't take as much damage under this algorithm, but I don't know if that's the right way of doing it. Maybe. But I ought to revisit this actually now, because we've got some actual data, haven't we, as to what the infection rate really is. But yeah, so just, you know, have a bit of fun with it. Feel free to drop me a line in the comments if you actually play around with it. If you say, you know, listen mate, you're a complete idiot and you don't know what you're doing. I know that already, so there's no need to tell me. There's no need to tell me that. But like I say, it was my first sort of reasonably large project in Unity, so it's a bit all over the place in terms of organisation and code style and all that sort of stuff. But if you're going to have a play around with it, have fun with it, and let me know how you get along.